Every year, the world's oceans welcome a new generation of giants. Steel leviathans so large they can carry entire cities' worth of goods across the globe. These aren't ordinary vessels, they're floating factories of logistics designed to haul thousands of containers filled with everything from smartphones to sneakers. But how are these colossal ships actually built? Today on The How Factory, we're heading inside the world's biggest shipyards to uncover how engineers transform raw steel into the largest moving machines on Earth. Cargo ships that connect our planet from steel to sea. It all begins with design. Before a single piece of metal is cut, naval architects spend months perfecting digital blueprints using 3D modeling software. Every bolt, plate, and bulkhead is simulated on screen to ensure the ship can handle enormous loads, turbulent seas, and decades of wear. The designs are optimized for balance, buoyancy, and fuel efficiency, because even a 1% improvement in drag can save millions in fuel over a ship's lifetime. Once approved, those designs become engineering drawings that guide thousands of workers across sprawling shipyards, stretching for kilometers along the coastlines of South Korea, Japan, or China. The global leaders in shipbuilding. Raw materials arrive by the trainload. Massive steel plates, sometimes 40 millimeters thick, coated in primer to prevent rust. Cranes unload the plates into cutting bays where automated plasma torches and laser cutters slice them into exact shapes. Sparks fly like fireworks as each piece is tagged, numbered, and sent to fabrication. In these workshops, welders and robotic arms bend, roll, and fuse the steel into curved panels and stiffened sections that will form the ship's skeleton. Every weld is inspected with ultrasound scanners to ensure there are no hidden cracks, because out at sea, even a hairline flaw could spell disaster. The ship is built in blocks, like an enormous puzzle. Each block can weigh hundreds of tons and contain multiple decks, rooms, and compartments. Workers fit ladders, pipes, wiring, and insulation inside the blocks before they ever leave the workshop. Then colossal gantry cranes, some taller than skyscrapers, lift the completed blocks into a dry dock the size of several football fields. There, engineers align them with millimeter precision, welding one block to the next until a recognizable hull takes shape. Day by day, the structure grows from a scattered collection of steel boxes into a seamless, streamlined vessel stretching more than 400 meters in length. Once the hull is complete, the next challenge is strength and balance. Internal frames called bulkheads divide the interior into watertight compartments, providing rigidity and safety. The double hull design, as a ship within a ship, adds protection against leaks and impacts. Engineers carefully calculate weight distribution to keep the center of gravity low and the draft stable. They even fill tanks with water during construction to test how the hull flexes under load, measuring stress points with sensors. Every plate and weld is documented in detail. A modern cargo ship is as much a database as a machine. Then comes the propeller system, one of the most critical parts of any vessel. These aren't simple blades, they're engineering masterpieces cast from bronze or nickel-aluminum alloy. Some propellers span 10 meters across and weigh over 100 tons. Each one is precision-milled, polished, and balanced so perfectly that vibration is almost non-existent. The propeller connects to a shaft running the length of the ship, powered by a massive slow-speed diesel engine, often the size of a small house. These engines can generate more than 80,000 horsepower, enough to move a city block through water at 25 knots. In the engine hall, technicians install turbines, generators, pumps, and miles of pipe. Cooling systems circulate seawater through radiators to keep temperatures steady. Fuel systems feed the engine with heavy oil that's preheated and filtered. Exhaust funnels rise high above the deck, equipped with scrubbers that clean pollutants before release. Modern ships now integrate hybrid systems and LNG fuel options to reduce emissions, a crucial step as the shipping industry races toward greener operations. As mechanical systems go in, electricians wire the ship's nervous system. Control panels, radar, GPS, and navigation instruments are installed on the bridge. Fiber optic networks link every deck, allowing crew to monitor temperatures, pressures, and alarms in real time. Below deck, massive ballast pumps are wired to respond automatically to shifting weight or waves. It's an orchestra of steel, energy, and code. Every subsystem must work together flawlessly for the ship to survive the open ocean. Meanwhile, outside, painters begin sealing the hull with multiple layers of anti-corrosion coating. The first layer is zinc primer, followed by epoxy and polyurethane. The final coat, often bright red below the waterline, contains special anti-fouling chemicals that prevent algae and barnacles from clinging on. Above water, the hull gets the shipping company's colors and ID markings, while draft lines are painted along the bow and stern to show how deep the ship sits when loaded. With hull, engine, and systems complete, the dry dock is flooded for the first time. Water rushes in as tugs guide the ship free from its building cradle. The moment it floats is the ship's symbolic birth, a ceremony often celebrated with confetti and champagne. Shipyard workers, engineers, and executives gather to watch their creation touch the sea for the first time. For months, it has been static steel. Now, it's alive and moving. Once afloat, the ship enters the fitting out stage. Here, crews install the remaining interior details: crew cabins, kitchens, lifeboats, safety systems, and navigation lights. Shipbuilders check every weld, tighten every bolt, and calibrate every sensor. In parallel, quality inspectors run endless tests: water tightness, electrical integrity, emergency drills, and fire systems. The vessel must meet international regulations set by organizations like the IMO and classification societies before it's allowed to sail commercially. The next phase is sea trials. The ship leaves port for the first time under its own power, escorted by tugs. Engineers monitor vibration, steering, and fuel efficiency as it navigates open water. They push the engines to full throttle, run turning circles, and simulate emergencies. Instruments record how the hull behaves in waves, and how the propeller performs under different loads. It's a real-world stress test designed to catch any weakness before the ship faces the unforgiving ocean alone. If the vessel passes its trials, it returns to the yard for final inspection and fine-tuning. Workers touch up paint, polish metal fittings, and install cargo handling equipment. The massive cranes, winches, and rails that allow containers to be loaded and stacked like Lego bricks. The bridge computers receive their final software updates, and crew members are trained on the latest safety and automation systems. Finally, the ship is officially delivered to its owner. A flag is raised, documents are signed, and the name is revealed across the hull. When a new cargo ship finally leaves its birthplace, its story is just beginning. Behind the sleek paint and powerful engines lies a masterpiece of coordination. A vessel designed to move nearly 90% of the world's traded goods. Before that first voyage, however, shipyards must prepare it for the work it was built to do. On the quay, towering gantry cranes rise like skyscrapers above the deck. Each one can lift containers weighing more than 30 tons, swinging them into position with centimeter accuracy. The ship's deck is lined with a grid of steel fittings that lock the boxes in place. Stacked 8 or 9 high, these containers form a steel mountain that still must remain perfectly balanced, even in rough seas. Software maps the weight of every container so the vessel's center of gravity stays safe. Below deck, massive ballast tanks pump seawater from one side to another to keep the ship level as loading continues. The process can take more than 20 hours for the biggest vessels, which can carry over 24,000 containers. Enough cargo to fill a freight train 70 miles long. Once the final lashing bars are secured and the hatches sealed, the crew readies the engines. A deep rumble echoes through the hull as thousands of liters of fuel ignite. And slowly the giant eases away from the dock. From the bridge, officers monitor dozens of screens: radar, GPS, sonar, weather, and engine diagnostics. Autopilot keeps the course steady while crew members handle maintenance, navigation, and daily inspections. Life aboard is a rhythm of 12-hour shifts, constant motion, and endless horizon. In the engine room, temperatures reach 50 degrees Celsius as engineers check gauges and clean filters. Every system must run perfectly, because once you're in the middle of the Pacific, there's no mechanic to call. These ships are floating cities of efficiency. Electricity flows from onboard generators that also power refrigeration units, keeping food, medicine, and electronics at precise temperatures. Fresh water comes from desalination plants that turn seawater into drinkable supply. Wastewater is treated and recycled. Some ships even recover exhaust heat to generate extra power, squeezing every bit of energy from their massive engines. A modern container ship may consume over 100 tons of fuel per day, yet move cargo more efficiently than any other transport on Earth. But efficiency alone isn't enough anymore. As climate goals tighten, shipbuilders and owners are racing to design greener fleets. New vessels run on liquefied natural gas or methanol instead of heavy oil. Others use hybrid electric drives powered by giant battery banks. Hull coatings have become ultra-smooth to reduce drag, and computer systems plot routes using real-time ocean current data to save fuel. The same shipyards that once focused only on size now compete to build the cleanest ships in the world. Automation is transforming operations as well. Sensors line every compartment, feeding data to the bridge and to satellite networks. Artificial intelligence predicts maintenance needs long before breakdowns occur. Some ports now use autonomous cranes and driverless trucks to load and unload vessels faster than ever. When a ship approaches, its systems sync with the harbor's network, so docking crews already know its weight, cargo type, and fuel status. Minutes after anchoring, unloading begins, a mechanical ballet of steel and precision. Inside the shipyard control rooms, engineers watch these digital twins, virtual copies of real vessels, to track performance even while they're at sea. Any anomaly, from vibration to temperature drift, appears instantly on their screens. If an engine runs hot, they can alert the crew or schedule parts for replacement before the ship returns to port. It's predictive maintenance at ocean scale, ensuring minimal downtime and maximum safety. The economic importance of these vessels is staggering. Every phone, car, shoe, and appliance likely spent time inside one of those rectangular boxes. Without them, global trade would slow to a crawl. Yet most people never think about the colossal infrastructure that allows everyday items to exist. Each cargo ship is a moving link in a vast network that binds continents together, from steel mills to ports, from factories to front doors. When the ship completes its maiden voyage, tradition dictates a celebration. Flags fly, horns sound, and the captain records the first log entry. For the shipbuilders watching from afar, it's the ultimate reward. Their months of welding, painting, and precision now gliding across open water. Some vessels will sail for more than 25 years, crossing oceans hundreds of times before retirement. Even then, the steel isn't wasted. Most ships are dismantled in specialized yards, recycled to build the next generation of giants. Back at the shipyard, new keels are already being laid. Cutting machines slice fresh steel, cranes thunder overhead, and another hull begins to rise. Each one a little faster, a little stronger, a little cleaner than the last. It's an endless cycle of innovation, a race to keep pace with global demand and environmental responsibility. Shipbuilding has always mirrored human ambition, the need to move, to connect, to trade, and to explore. Standing on the dock beside one of these finished ships is an almost surreal experience. You feel the ground tremble under its weight, its sides tower higher than a 10-story building. And yet, when the mooring lines release, it slides away with effortless grace, a skyscraper in motion. What began as cold sheets of steel has become a living machine, guided by satellites and crewed by men and women who carry the heartbeat of global commerce across the oceans. Every bolt, weld, and circuit represents centuries of progress, from wooden sailboats to digital superships. And as technology advances, the next generation will push even further. Hydrogen fuel cells, autonomous navigation, and fully recyclable materials. The dream is to create ships that leave almost no trace behind except ripples on the sea. So the next time you see a container ship on the horizon, remember the journey hidden inside it. The sparks of the cutting torches, the echo of hammers in the shipyard, the first splash as it touched the water, and the crew steering it through endless waves. It's more than steel and cargo, and it's proof of what humanity can build when engineering, industry, and imagination meet. That's how giant cargo ships are built, from steel to sea. Thanks for watching The How Factory, where we uncover how the world really works. Don't forget to like, subscribe, and join us for more stories of the machines and people that keep our planet moving.